Welcome to Ask and Learn.
All right, guys, we're going to do problem number 110 in chapter 5, Chemistry to Central Science. They want us to find the delta H of this reaction using these reactions right here. There might be a typo in your textbook. There was in mine. They had this as 1H2. It should be 2H2 because there should be 8 hydrogens on the right, just like there are 8 hydrogens on the left. Anyway, let's get started. So, first off, we're going to start with the left side. Let's find all the equations with CH4 on the left that contain CH4. And it looks like this is the only one that does. So we're going to put that over here. But important to remember, this has one CH4, and we have 2 over here. So we're going to need to double this. That's plus 4O2. Yields 2CO2. Plus 4H2O. So now we have to double this. So minus 80.3 times 2 is 890.3 times 2. So delta H is equal to minus 780.6 kilojoules. Well, okay, so we can cross this one out. We're done with it. Now we're going to look for the equations that have H plus, and we're going to put them on the right. Sorry, H2 plus. So this one has C2H4 and H plus on the left. So we have to flip it. Put those both on the right. And C2H4 gas and plus in as an H2 gas. And because we flipped the equation, we have to also flip the sign of delta H. So 136.3 kilojoules. 6, so we get rid of this. So now we have, so we're going to put this on the right. So we have 2H2O, a liquid, yields 2H2 plus water, 2H2 plus O2. Gas. So we have to flip the sign. $571.6 kilojoules. And we have and we're going to put, and the last one, this has none of what we're looking for in our overall equation, but it as C2H6, so we're going to put C2H6 on the right so we can cancel out with this C2H6. So 4CO2 gas. yields 2 C2H2. But since we only have one C2H2, we're going to divide this by 2. So this is going to be 2, this is going to be 3. Plus 7 over 2 to O2. So since we flipped it n divided by 2, we have to flip this n divided by 2. Equals 1560. So delta H is equal to 1560.4. Now, to simplify how we're going to do this, I'm going to place this as 8 over 2. As opposed to 4. So let's see what cancels out so far. See, this cancels out with this. Now we have 2 CO2 canceling out. So we have 3. So we have 5 waters on the left. So we're actually going to divide this equation by 2 now. Let me just rewrite it so we have more room. One half. So now we have 4. Now we have 3, 4 waters on the left, 4 on the right. These cancel out. And before we do anything further, let's not forget to change this delta H value. So we're going to change it from 571.6 divided by 2 to 85.8. It's going to make it like this so it's easier to take out. Kilojoules. Now, we have 2 CH4 on the left, 1 C2H. We have 2 methane on the left, 1 C2H4 on the right. You have 1 2 H2 on the right, so everything's good there. I forgot to cross this out. So now we have 8 over 2 oxygens on the left, and we have 7 over 2 plus 1/2 oxygens on the right. So 1/2 plus 7 over 2, that's 8. So these also cancel out. So now that gives us our overall equation. 2 CH4 yields C2H4 gas plus 2H2 gas. So now then our delta H value is just going to be the sum of all these values. So 136 plus 283.8 plus 1560.4. Just make sure everything looks good. Good, plus negative 1780.6. That is going to equal to 201. That's a positive 201.9 kilojoules. So the key to solving this kind of problem is you have to figure out what's going to be on the left, what's going to be on the right, and then work from there. And then you're going to So well, we start off by figuring out, we know that CH4 is on the left, C2H4 is on the right, and H2 is on the right as well. So we set up those specific equations, and then we figure out how to cancel everything out. So when we go into this equation, this has none of the compounds in our overall reaction. We only have this on the right because C2H6 is on the right, and that will cancel out this C2H6 over here. So the key to understanding this problem is knowing how it's like an algebra problem. You should know where everything is so you can cancel it out.